So hello friends, welcome back to our YouTube channel Explore with Fun. Today we are going to study the physics of class 9 S.chand numericals. So the first chapter of the class 9 physics is motion. So we will deal with the numericals of the chapter number first, that is motion. So basically the chapter number first, motion, is divided into the two modules. We will discuss the first module here in lecture number 1, and we will discuss only the numerical, not these basics questions. So we will start from the first question of short answer type, that is question number 23. So let's start with the question number 23. The question number 23 says that bus X travels a distance of 360 km in 5 hours. Means there is a bus X which travels the 360 km in 5 hours. And then they are saying that bus Y travels the distance of 476 km in 7 hours. So we have to tell that which bus travels the faster. So we will directly use the speed formula here in this question with speed equals to distance upon time, and the distance is 360 km and time is 5 km. So the speed of the bus X will be 72 km per hour. So now let's see the bus Y. So the bus Y speed will be equals distance upon time. So that speed of the bus Y will be 476 upon 7. So basically what will be the speed of the bus Y will be 68 km per hour. So now we can see that bus Y speed is 72 km and the bus X speed is 72 km and bus Y speed is 68 km. Now we can directly say that which bus travels faster. So the bus X travels faster than bus Y. Okay friends, so now let's go to the second question. So what is the second question is that arrange the following speed in increasing order, keeping the least speed first. So the part first of the question number 24 is an athlete running with a speed of 10 meter per second. Athlete is running with 10 meter per second. And second question option is given that a bicycle is moving with 200 meter per minute. And third option is given that a scooter moving with a speed of 30 km per hour. Scooter moving with 30 km per hour. So basically we have to change them in increasing order and keeping the least speed at first. So basically we will change these all three in a one form. So let first form be like this only. Now we will deal with the second one. So second one is given that 2 meter 20 meter per minute. So in 1 minute we can say there is a 60 second. So we have to make it also in a 10 meter per second in a meter per second form. So what we will do, this 200 meter is already given and in minute we will change into the second. So in 1 minute there are 60 seconds. So we will divide 200 meter by the 60 second. So what the answer we will get, that answer we will get from this, it will be 10 upon 3. So we can say that 3.3 meter per second. Okay, this we got as 3.3 meter per second. Now we will deal with this third option. The third option is given that 300 km per hour. There you know that there are 1000 meter in 1 kilometer. So 30 km equals to 30,000 meter. So and the hour means in 1 hour there are 60 minutes and in 1 minute there are 60 seconds. We can say there are 3600 seconds in 1 hour. So we will divide them. So what we will get? We will get the value, that is 8.3 meter per second. So the value of this will be 8.3 meter per second. So now we can arrange them in a ascending order. See, first we will get the 3.3 meter per second, that is option number second. Okay friends, 3.3 meter per second. Then and second there we will get 8.3 meter per second, and then it is there 10 meter per second. So they are arranged in a increasing order, or we can say in ascending order. See, the least speed is kept first 3.3 meter per second, 8.3 meter per second, and 10 meter per second. So this is the answer of the question number 24. Now let's go to the question number 25. So what is question number 25? Basically the question number 25 is divided into A and B. In A part, they are asking about the acceleration formula and its symbols. So let's discuss first about question number A. They are asking about acceleration formula and its symbols. So the formula of acceleration is given as A is equals to V minus U upon T. And they are asking to define also these symbols. So we define A as a acceleration, V as a final velocity, and U as the initial velocity, and T we define as a time. So now we understand the formula of acceleration. Now we will go to the part second. So what is part second? At part second there is a numerical. So now let's deal with the part second. So the part second is a train starting from a railway station attains a speed of 21 meter per second in 1 minute. Means they are asking that a train is there at a railway track. We can assume it as a railway station, and the train is standing here. Means its initial velocity is 0 meter per second because it is in rest. Okay friends, and it attains a speed of 21 meter per second. Means it started to attain a speed of 21 meter per second. Means we can say it as a final velocity, and the time taken to attain this speed is 1 minute. So we have to find out the acceleration. So formula of acceleration, you know only that it is V minus U upon T. So the V is U is 0, V is 21 meter per second, and the time taken is 1 minute, or we can say that 60 seconds. So now we will put them in an acceleration formula, that A is equal to V minus U upon T. So A is equal to V, we are given that 21 meter, and U is 0. So time taken is 60 seconds. So what is the acceleration? You can comment me in the comment box. So the acceleration will be, we can say that it is 21 upon 60 meter, and we can define means when we will divide it from each other, we will get it is 67 upon 20 meters. So or we can say it also the 0.35 meter per second square. So the acceleration will be 0.35 meter per second square. Students, this thing you have to keep in mind, that the value of acceleration will always come in meter per second square. So this is our answer of 25 question part B. So now let's move the numerical number 27. So friends, the numerical number 27 is saying that a snail covers a distance of 100 meter in 50 hours. Means there is a snail, we can say that there is a snail. It covers the distance of 100 meter. It covers the distance of 100 meter, and the time taken to cover this distance is 50 hours, and we have to change this unit into kilometer per hour. So what we will do? See friends, this is given that 100 meter, and we have to change it into kilometer, and this is given in hour only. So we will do that 100 meter, we will change it into the 100 meter, we will change into the kilometer. So what we will do? 100 meter divided by 1000 equals, we can say that it is converted into the kilometer, and the r we have given only first only. So we will directly put the speed formula, that is distance upon time. So distance is our 100 upon 1000, and the time taken is, we can do divide by 1 upon 50, divide by 50. Okay friend, so what we will get answer? 100 upon 1000 multiply, it will get inverse 1 upon 50. So 0 0 cut, and we will get 1 upon 500. 500, 1 upon 500 we got in and when we'll convert it into the decimal, we will get the answer that 0.002 kilometer per hour. So friends, the answer of this is that 0.002 kilometer per hour, means a snail is traveling 0.002 kilometer per in 1 hour. So now let's talk about the next question, that is question number 28. So basically what the question number 28 says that a tortoise moves a distance of 100 meter in 15 minutes. What is the average speed of tortoise in kilometer per hour? It is also the same question. They are asking that there is a tortoise and it travels the distance is given into 100 meter and the time given is in 15 minutes. Minutes, and we have to convert this into kilometer per hour. So I have told you that how we will convert. So it is given in meter, so we will first convert this into kilometer. So in 1 kilometer there are 1000 meters, so we will divide it by 100 upon 1000. It converts into the kilometer, and now we will deal with this time. It is also given 15 minutes and we have to convert it into hour, so we will divide it by 60. So 15 upon 60 becomes hour. So now we will place them in a formula of speed, that is distance upon time, and distance is given over 100 upon 1000 and the time is divided by time is 50 upon 60. So what we will do that 100 upon 1000 multiplies, it will become inversely, means it will get reverse 15. So 0 done, 0 cut. So we got 6 upon 15. So when we will cut it, we will get the value that is 0.4 kilometer per hour. I think it will get in approx. So there is the tortoise which moves the distance 0.4 kilometer in 1 hour. So it is our answer of question number 28. Now let's move to the question number 29. So basically what is question number 29? So the question number 29 is, if a sprinter runs a distance of 100 meter in 9.83 seconds, so calculate his average speed in kilometer per hour. So we will do what we have done in question number 28. So what is distance? Distance is our 100 meter and our time is given into 9.83 seconds. So first we will convert this 100 meter into a kilometer per hour, that we know it is 100 upon 1000, and this 9.83 second we will first convert it into hour, that hour. So that we will do that 9.83 we will divide it by 3600 hour. We know that there are in 1 hour there are 3600 seconds. So what we'll do that 9.83 9 point we will remove and it will come downside 100, multiply by 1 upon 3600. So we will write this 983 upon 36000. So this came value in second, hour. So now we solve the question. The formula we know that distance upon time, speed formula. So what we will do that 100 upon 1000 divided by 983 upon 36000. So 100 upon 1000 multiply by 36000 upon 983. This 30 cancel from here. Okay friend, so what we get 36000 upon 983. So when we will cut this, we will divide to each other, we will get that 36.622 kilometer per hour, or we can say only that 36.62. we will do it round off, then we will get the value 2 only. So we will get 36.2 kilometer per hour. So friends, this is the answer of our question number 29. So now let's move to the question number 30. So friends, what is question number 30? A motorcyclist drive from place A to B with a uniform speed of 30 km per hour. Means this is A to B. There is a motorcyclist which drives the speed of 30 km. Means at first case the speed is 30 km per hour. Okay friends, and the distance we don't know, so we will let it x. And in second case it is telling that it returns from place B to A. Means it is returning from B to A. So from distance will be same, but speed it comes with a uniform speed of 20 km per hour. So what we will do here, we have to find the average speed. So the average speed formula is total distance taken upon total time. So time also we don't know here, but speed and distance we know here. So what we'll do, time also is equal to distance upon speed. It is the time for this one, A to B, and times for B to A will be x, distance will be same, so we can say that x upon 20. Simple. So now we will place it into the average speed formula, that is total distance upon total time taken. So what we will do now, we will place the distance, total distance means distance is same, x plus x on both sides, and total time is x upon 30 plus x upon 20. So x plus x becomes, or we can say it, we will cancel this x and this x, this x and this x. So what is remained now? So remaining part is upside 1 plus 1 remained, and downside 1 upon 30 plus 1 upon 20. If we will plus them, so we will get that 2 divided by, we will say that 5 upon 60. So now what we will do, so we will do this 5 upon 60 remain. Now we will cut this, do that 2 multiply 60 upon 5. When we are doing it inversely, then it is getting a reverse when we are dividing. So what answer we will get, that answer is 24 km per hour. Means this is the average speed of motorcyclist. So our answer number 30 is 24 km per hour. So now let's move to the answer number 31st. Question number 31st. So friends, what is question number 31st? It is there saying that a motorcyclist starts from rest and reaches a speed of 66 meter per second after traveling with uniform acceleration of 3 seconds. What is his acceleration? Means we have to find out the acceleration. So the motorcyclist start from rest. We can say that initial velocity will be 0 meter per second because it is starting from rest, and it reaches a speed of 6 meter per second. Means it is starting from rest and reaches 6 meter per second speed in time 3 seconds. So we can say that initial velocity will be 6 meter per second, and the time taken by the body to move is 33 seconds. So we have to find out the acceleration. So simple, we will put them in the acceleration formula. So what is the acceleration formula? Acceleration formula is v minus u upon t. So a is equal to v we know only 6 meter, and u is 0, and t taken is 3 seconds. So simple, the acceleration is 6 upon 3 or 3, or we can say that acceleration equals to 2 meter per second square. Simple. So this is the answer of our question number 31st. So now let's move to the question number 32. So friends, what is our question number 32? So our question number 32 is, an aircraft traveling at 600 km per hour accelerates steadily at 10 km per hour per second, taking the speed of sound as a 100 km per hour at the aircraft altitude. how long will it take to reach the sound barrier? Means we can say that aircraft is moving at a 600 km per hour speed, so we can say that initial velocity of the aircraft will be 600 km per hour and accelerates steadily at 10 km per hour. Means acceleration is 10 km per hour per second, and taking the speed of sound barrier, the speed of sound barrier will be 1100 km per hour. We can say it is also final velocity, and this is a u and this a. So we have to solve this from this first equation of motion. So the first equation of the motion is v is equal to u plus at. This is the first equation of motion. So we cannot solve directly it from this because here t is given. So we will little bit means change it. We will manipulate it. So what we'll do? This u will come this side, then we will do minus, and this a will come down, so it will come in a and equals to t. So this formula we will get, and we will put these values in this one formula, and we will get the answer. See how. We know 1100 km minus u is 600 km, and the acceleration is 10 km per hour. So what we get? We will from 1000 we will minus 600, we will get 500 and upon 10, so cancel 10. So the time taken for the aircraft to reach the sound barrier is 50 seconds. So this is our answer of question number 32. Now let's move to the question number 33. So what is question number 33? If a bus traveling at 20 meter per second is subjected to a steady deceleration of 5 meter per second square, how long will it take to come to rest? So we have to find a deceleration, or we can say retardation. Steady मतलब क्या होता है? अचानक. So now let's read again question carefully. So if a bus traveling at a 20 meter per second, means we can say that u is equal to 20 meter per second. Simple. And is subjected to deceleration of 5 meter per second square, means it is having a deceleration. So we can say that negative acceleration, that is we have 5 meter per second square. Now what is it saying? How long will it take to come to the rest? Means its final velocity will come to 0. How? See, it is a bus traveling at a speed of 20 meter per second. If suddenly it will apply brake here, means this will come and it will slowly move and stop here, means कहीं ना कहीं इसकी final velocity 0 होगी. So that we also wrote here. So we will put it into the acceleration formula, that is a is equal to v minus u upon t. So we know v is 0 minus u we know 20 upon time taken 5 seconds. So acceleration is equals to minus 20 upon 5, or we can say x is equals to 4 minus 4 meter per second square. We can call this also minus 4 meter per second square, or we can call it deceleration is equal to 4 meter per second square. So this is our answer of question number 33. So friends, आज के लेक्चर में हम लोग बस इतना ही डिस्कस करेंगे, और जो मॉड्यूल फर्स्ट रिमेनिंग क्वेश्चन है वी विल डिस्कस इन द लेक्चर नंबर 2. सो आज के लिए बस इतना ही. बाय बाय. वी विल मीट इन द लेक्चर नंबर 2. प्लीज सब्सक्राइब अवर चैनल टू गेट द नोटिफिकेशन ऑफ अवर वीडियोज. सो टाटा, बाय बाय.